about optimization problems, and this time we're going to involve exponential functions. So the effectiveness of studying for an exam depends on how many hours the student studies. So some experiments show that if the effectiveness of E is put on a scale of 0 to 10, okay, so that's basically what we're going to punch out, then we can call E at T equals 0.5, 10 plus T e to the negative T over 20. Okay, where T is the number of hours spent studying for an examination. If the student has up to 30 hours for studying, how many hours are needed for maximum effectiveness? So first, we can simply find out how many hours does he have to study? Up to 30. Okay, so up to, that includes 30. So T is going to be in the interval between 0 and 30. So let's go ahead and find where the critical points are by solving for the derivative of E at T. Just for laziness, I'm actually going to expand this in first. So E at T equals 5 plus 0.5 T e to the negative T over 20. Okay, now let's solve for the exponent, or sorry, the derivative. Derivative of 5 is nothing, okay? I'm going to pull out 0.5 and we're going to do the constant rule. So let's do the product rule actually. Okay, we're going to do 0.5t times this e function. So derivative of the first thing times the second thing plus the first thing as it is times the derivative of the second thing. So e to the negative t over 20. Then we're going to have to multiply that by the derivative of the exponent here. So negative 1 over 20. And that's it. Because if you take a look at negative t over 20, this is just like saying negative 1 over 20 t. The derivative of t is, it just goes away and we just talk about the constant or the coefficient. Whenever I have something really like longer and ugly looking like this, what I do is I try to make it as simple as possible. So I'm actually going to factor out 0.5 e to the negative t over 20. Okay, and we get 1 plus we have this t and this negative 1 over 20 left, so actually minus 1 over 20t. Okay, so when does this equal 0? 0.5 e to the negative t over 20. When does that equal to 0? And when does 1 minus maybe t over 20 equal 0? So if we review e to the anything, it's never actually going to equal 0. It's always going to be increasing or decreasing. There's never going to be that horizontal asymptote. Okay, so no solution. Now let's bring this over. Bring this whole thing up here. Okay, we get 1 equals t over 20. Okay, cross multiply, 20 equals t. So we have a critical point at t equals 20. Now all we're going to do is we're going to test the two endpoints and the critical point. So we're going to test e at 0, e at 20, and e at 30. What do we get? Okay, I did these on my calculator. If you plug this into the original, we get 5, we get 8.7, and we get 8.3. So this is the maximum score here. So therefore, if a student studies um, 20 hours, they will have maximum effectiveness. Okay, example 2. A mathematical consultant determines that the proportion of people who will have responses to the advertisement of a new product after it's been marketed for 2 days is given by this equation. And I always rewrite the equations. 0.2t. There we go. Okay, the area covered by the advertisement contains 10 million potential customers. Okay, so the number of people is between 0 and 10 million. And each response to the advertisement results in a revenue to the company of 70 cents on average, excluding the cost of advertising. The advertising costs $30,000 to produce and a further $5,000 to run per day. I just have to know. This is people. Okay, determine the limit as t approaches infinity of f at x, or sorry, f at t, and interpret the result. So let's do the limit as t approaches infinity of 0.7. And of course, that's just 0.7 because it's a constant. Now, times the limit as t approaches infinity of 1 minus e to the, let's say, negative infinity. Okay, e to the negative infinity goes to 0, right? Because if we were to take a look at this function here, I always do this really quick in my head. This is e to the x. So if we had it decreasing, this would be e to the negative x, and then we would flip it, and we'd have negative e to the negative x. So if we take a look at this equation, when we sub it infinity, it's going to approach 0. So that goes to 0. 1 minus 0 is just 1. So it's like 0.7 times 1, which is just 0.7. Okay, and what does this mean? This means that if the advertisement was left in place forever, because of course t approaches infinity, right? The time approaches infinity, 70% of the people will continuously respond. Okay, B. B asks, what percent of potential customers have responded after 7 days of the advertisement? Okay, is we have f at 7 equals 0.7, 1 minus e to the negative 0.2 times 7. Okay, remember from up here, t is the number of days. Okay, so we can just plug the 7 right in, and I get 0.53. Do that in calculator, just make sure. That means 53% of people responded after 7 days. Okay, C, write the function P at T that represents the average profit after T days of advertising. What's the average profit after 7 days? All right, I just cleared my board. So when we talk about, we need to talk about the profit function. Okay, P at T. So the average profit is going to be the difference between the average revenue received from all customers responding to the ad and the advertising costs. Okay, and since the area covered by the ad contains up to 10 million potential customers, the number of customers responding to the ad after T days is 10 million, so 10 to the 7, okay, times the function of people who actually responded. So this is going to be the percentage of people who responded times our 10 million. So it's going to be that many people. So there's that chunk of it. Okay, if we multiply this 10 to the 7 by 0.7, we're going to get like 7 times 10 to the power of 6. And then we're going to get 1 minus e to the negative 0.2t. We're not at profit yet. Let's go to respondents. Respondents at time t. This is going to be how many people actually respond to the post. Okay, so it's going to be a number of people. The number of respondents. Now, how much are they going to make? Well, we see each response to the advertisement results in 70 cents on average. Okay, so the revenue that we're going to actually take in is going to be 70 cents, 0.7, times the number of respondents that actually respond to the post, the advertisement. Okay, so if we multiply 7 times 10 to the negative 6, or sorry, to the 6, we're going to get that 4.9 times 10 to the 6. Okay, just to simplify things, keep it easy. So that's how many people actually respond. Now, the cost for the advertisements. Okay, it says up here, advertising costs is $30,000 to produce the actual advertisement and $5,000 a day to run it. Okay, so it's 30,000 plus 5,000 per day, and that's the cost. Okay, so if we're actually just talking about profit, let's actually think of a profit function. So we're going to do the revenue minus the cost. Okay, the revenue, 4.9 times 10 to the 6 times 1 minus e to the negative 0.2t minus, and then the cost, remember the cost is going to be in brackets. So we're actually going to subtract $30,000 and we're going to subtract again 50,000t. Okay, therefore, after 7 days, what is the profit? Okay, let's plug in 7. So we have 4.9 times 10 to the 6, 1 minus e to the negative 0.2 times 7, minus 30,000, minus 50,000 times 7. Okay, if you put that in your calculator, we get 3,627,000, and that's approximate. Okay, dollars. So that's going to be the profit after 7 days. Okay, and now D. For how many full days should the advertising campaign be run in order to maximize the average profit? Okay, and assume an advertising budget of $20,000. Okay, let's cut and paste D. Okay, so here's our profit function and here's part D. So we know that the advertising budget, which is just this part at the end, so 30,000 plus 50,000 T, it has to be less than or equal to 200,000. Okay, so bring over that 30,000, divide by 50,000. Okay, we're going to have T has to be less than or equal to 34. Okay, so our two endpoints are going to be 0 and 34. So let's go ahead and find the critical number. So let's find the derivative of P at T. So 4.9 times 10 to the 6 is just a constant. So let's just leave that. Okay. And then let's do the derivative of 1 is 0. And the derivative of negative e to the negative 0.2. So we have negative e to the negative 0.2 t. And we're going to do the derivative of what is in the exponent, negative 0.2. Okay, derivative of 30,000 just goes away, and the derivative of 50,000 is, sorry, negative 50,000 t is negative 50,000. So if we multiply this, 4.9 times 6 to the negative 2 times negative 0.2, we get 9.8 times 10 to the 5. Okay, e to the negative 0.2 t, oh yeah, and also multiplied by that, then minus 50,000. So when does this equal 0? Okay, so when does 50,000 equal 9.8 times 10 to the 5, e to the negative 0.2 t? So let's divide both sides by 9.8 times 10 to the 5. 9.8 times 10 to the 5. And I know I usually skip over a lot of this work if it's really easy, but this one a little bit more difficult. So 9.8 times 10 to the 5. Okay. I get 0.05102. Okay, let's round it to there. Equals e to the negative 0.2t. Okay, how do we get this exponent down? I'm going to ln both sides, ln and ln. Okay, so I'm going to bring this down. So I have ln of 0.05102 equals negative 0.2t ln e. That ln e goes away. And we divide both sides by negative 0.2. Okay, so I get t equals, make sure this works on my calculator. So ln 0.05102 divided by negative 0.2. This is 5,000. Sorry, and I did it with 5,000 too. Okay, so there should be another 0 in there. Okay, so I get time equals 26. Okay, so therefore we have to plug in p at 0, we have to plug in p at 26, and the other endpoint p at 34. Okay, so p at 0 is actually that they're losing money. It's like negative $30,000. Okay, p at 26 is 4713000, and then p at 34 is 4695000. So this is clearly the greatest value. So the maximum profit of 4,713,000 when the ad campaign, the ad runs for 26 days.